ever read on how to actually get started. Here, wait, let's see. I think I've got this thing. I think I've got this ready, queued up. Oh, it's in the wrong spot. Here, I'll move it over my head. And now I have to move it up. Okay, the do's and don'ts of deploying. I'm going to put it over his head too so you can see it. The do's and don'ts of deploying AI for retailers. One of my favorite articles ever. So with that introduction, that's enough of me. Let's talk to Dean and see how he's doing.
Wow. Well, John, I mean, with that kind of intro, I mean, it can only go downhill from there because with saying such glowing things. But I'm glad you liked it. And this is AI is such a passion of mine. I've been doing data science stuff for over 30 years now. So
Only
I'm doing
30?
only 30, yeah, 31 years.
What's that? Looks like a diploma behind you. Are you legit?
Oh, yeah, that's so I went to University of Virginia, got a master's in applied math there. I am unencumbered by a
Oh,
PhD,
I would
but
love
my
that.
undergraduate was computational math from Rensselaer Polytechnic Institute, got a master's in applied math. So I'm kind of a math geek who
Oh, that's
became
so
practical.
exciting. I won the high school math award for the state contest in my high school, and I was in the 80th percentile of the finalists around the state of Wisconsin. And the reason I didn't win was because they saved your computational sheet, and I made a math error, but I got all 5 out of 5 questions right, but they said you made a math error and still got it right. And so I didn't win the state contest, but I got all these scholarship awards. But the reason I made a math error is because I had trouble with add, subtract, multiply, and divide. So
Right?
when I went to Madison and I did the aptitude test, they said, well, you can't take math unless you take remedial math for people who basically failed it in high school.
That's
So
terrible. But
yeah,
that's arithmetic is different than theoretical
yeah,
mathematics and real analysis. It's really a different skill set.
yeah.
My
So
wife
I
laughs at me at my math errors too.
I went
So
into philosophy, got an MA in philosophy, and I I actually the chairman of the department told me that he thought I had solved a 75-year-old philosophical puzzle. Like these impossible quizzy questions that if you saw Impossible Mind, I mean, what was that guy? What was it? John Nash?
okay, yeah,
Whatever it was some or Beautiful Mind. I finally
beautiful
went.
mind. That's it.
Yeah, I finally went and saw it because all my friends kept saying, "You should see this. This guy's you." And what's funny is I had actually done my thesis, my undergrad thesis in philosophy I spent a lot of time at the Princeton Library where he was at the time, which is crazy, right?
Mm.
But so I love math. I taught my kids when they were growing up that God loves math, and math is the universal language, and they thought I was crazy. But
Well, I won't dive too deep in that hole, but sometime we've got to talk about philosophically the universe and mathematics and the mind of God. It's a fascinating
I
uh,
I
thing to
I,
talk about.
I have a book I want to write. Maybe we could collaborate, which is basically the will of God as game theory. And the trouble is, I went and got a bunch of books on game theory, and it's way beyond me mathematically. But that's not what I meant by game theory. I meant fundamentally, what's a good game? Like a somehow a level playing field that allows the demonstration of skill was kind of where I was headed with that.
Hmm. Interesting. Yeah.
Yeah,
So
but let's not get off on this
we will.
crazy stuff. I want to revisit your. How is it that you? I mean, do you work with retailers? Do you actually wrestle with these um, with trying to do something with data?
Yeah, I do. And so, like I said, I've been doing this stuff for 30 years, but I started early in my career as more Department of Defense kinds of things. I love differential equations and control systems, and I was doing missile guidance in the early smart bomb days. But later in my career, I started moving more into customer analytics.
Okay.
And this company was founded in about 2009, and specifically looking at how you can apply machine learning and this style of analysis to retail. The good news about retail is, I mean, retail, and from the CRM world, there's always been a lot of data. And really, retailers have been at the forefront of advanced analytics for a long time. And a lot of it's because there is a significant amount of data. The problem is the data is awful.
I know, and it's
And
not very well tied to who bought.
it's not tied to you. So, what at Smarter HQ, the thing we've been able to do to improve the data is, first of all, tie together all the sessions that a shopper is engaged with. We do this thing more broadly speaking, described as customer identity resolution. So we stitch together from tracking cookies and any personal data we have about a shopper, what their holistic picture is. So you can think of it like a graph or a social network of a shopper engaged in this web browser and this web browser and a mobile app and all these different things. So they've exposed their email address. So you stitch together all of
Exposed. I like
the
that. You better not say that too
yes.
many times.
Well, if it's deliberate, if it's intentional for the purposes the data was to be collected for, and I'm speaking GDPREs and
I
soon to
know
be
CCPA. I
CCPAs,
know.
yeah, but actually, it's actually, to me, it's not a real bad thing. I think there are some disturbing aspects of CCPA that I still don't understand yet, but the uh, the gist of it, I think, is good. That as individuals, we should have some level of
Yeah,
understanding. There
but
should be transparency
how do you
what the data
send
is
it
being
to the
used.
consumer when all it is a bunch of numbers and a big, hugenic amount of
I don't
columns?
know. I don't know what they're going to do with it. Like I could
Yeah,
send them all
right.
the session interactions, everything they've got. Have at it.
Yeah,
Do what you want with it.
yeah. Out of the
But
box, we build about 300 variables per customer. So, okay, yeah, let's send them that. See what they think.
yeah,
It doesn't make any
you know,
sense.
it won't make any sense to them. But you're right. The interesting thing about this data is it's also very wide. If there's a lot of different characteristics you can use to describe the behaviors, the historic behavioral characteristics. So the data is relatively rich as long as it's populated. I mean, missing
Well, there's
data,
another big issue.
data's always been a problem. Right. That's always been a problem.
Yeah.
But the nice thing about the digital world, that's different from the old brick and mortar style of things. In the brick and mortar world, you'd have access to transactions, and that's about it. So you
Yeah.
know what they ultimately did, but you don't know how they got there.
Right.
It's really what we're trying to uncover with digital marketing, and this is what Smarter HQ tries to do, is what is the intent of the shopper. So when a shopper browses a category page and then drills down, clicks through, looks at three different detail pages, and then carts something and then abandons the cart. What are they really trying to do with that experience? They're in the cart, they interact with payment methods 4 times, and then they leave. What do they do?
That's what I do.
You know,
Oh, I bought a little
right?
stuffed animal the other day, and it's like I had to battle this shopping cart software. I could not get it to take my order to save my life. I bet it took me 20 minutes to check out.
And some of those experiences are awful, but the worst thing the retailer can do is say, "Oh, you had abandoned your cart. Let me put you right back where you were before and let you continue to
Yeah.
battle it out." We've had that experience with like credit card payments.
Yeah.
Somebody messes up their security code, and the last thing we want to do is send them back to that page so they can mess up again. Then,
Oh,
if you uncover that kind of experience, you send them to the call center and have somebody
what an
help them complete.
idea. That's a great idea. I like that one.
Yes. So that's what we're trying to do
I was
from
ready
a
to go to Amazon. I almost did it, but I wanted to buy from them directly so that they send me catalogs and stuff. And people are
so do
learning
you
that
do
now.
that?
People are learning that you're better off buying it from the merchant
Yeah.
than buying it from the merchant through Amazon. Even with the shipping.
And it is Amazon against the world right now versus everybody else in
Yeah.
retail. I mean, we've a lot of the clients. We have some high-end clients in our portfolio at Smarter HQ, and they're of course very concerned about Amazon. How can they provide a better shopper experience than Amazon does? And one thing they can do that Amazon's still catching up on is with the in-store experience, which is a different experience. And a lot of shoppers will do window shopping online and then they'll finally transact in the store, especially for fashion and apparel. And Smarter HQ even did we did a survey of millennials to try to uncover what their preferred style of shopping is. And 50% of millennials that responded to the survey said they preferred an in-store shopping
Oh
experience,
yeah, you know,
which is
and they
fascinating.
like mail
Now,
too. That's the weird part. If
yes,
you saw some of
but
my, if you saw some of my, I do this daily, not interviews. Interviews
yes,
is new, and I tried to edit them, and now I'm just letting everybody talk. But one of the things that I get a kick out of it, because I've been doing this 25 years modeling, and for retail and for catalogs. My very first big client was the Hudson Bay Company in Canada, which was a $5 billion company at the time. And
yes.
on a good month, 20 million transactions, and we poured that into a Pentium. Uh, you know, with nobody believed it was possible. Microsoft hired me just to see what I did, and it was hilarious.
What did you do?
We used
How did you do it?
Interbase, and my brother helped me a lot, and he knew computers from how the data gets laid on the drives. I mean, he knew, and we had
Yep.
and I remember when we got our first 1 gig drive, hard drive, and we had like 30 of them paper clipped around the stripped off cabinet of this Pentium, and we had the number 5 Pentium that NCR ever built. They
Wow.
shipped us one of the first 5, and we blew the motherboard 5 times. And finally, Ted said to the repair guy they kept sending out, "Would you like to know why the motherboard's blowing up every time?" He said, "Yeah, that might be a good idea." And
But
we fixed it.
that's fascinating though, because it does matter. I mean, at the performance you're trying to achieve, how the data is laid out on the disk, which platter, all those
Yeah,
details
and read
matter.
ahead caching and this stuff. So
Yes.
yeah, so one of the times before we actually lit it up and got it running, I said to Michael, who was working at Borland on Interbase, one of the programmers would call us, right? You never get to talk to those guys, but they would call us. And I said, "Hey, Michael, nice. Now that I'll transfer you, but now that I got you on the phone, what do you think the read write capability is of Interbase, on a Pentium?" And he said, "Well, the best we've ever heard of is 6 records a second, and we think that listen to this part. We think the theoretical limit is 10." So I didn't, I didn't know how many seconds 250 million transactions would be. About 25 million seconds at that rate. But I figured it was
Right.
more than we could stand in the length of the contract. Well, anyway, so I said to Ted, "Are this can't possibly work." He said, "They don't know what they're talking about." So when we lit
Well,
it,
that really is that gets at the biggest difference between the way machine learning works now and
yeah,
back in the
yeah. Oh,
day.
it's totally
It's
different. But
it's just
we did it.
it's hardware.
Yeah.
It's hardware because the algorithms are the same. Neural networks have not changed. I mean, yes, there's some deep learning flavors of neural
Yeah, and they
networks
play
now
computers
that
against
are
each other
cool.
instead of against a learned data set or a labeled data set. But sometimes, if they can, if it's a tightly constrained
But
game.
right, but the math is pretty much the same. The big difference is how much data we can process
Yeah,
because hardware and software, especially the hardware, is so much better. I mean, we at Smart HQ we live in the AWS ecosystem and we use Redshift for a lot of our uh, data processing.
yeah, we don't. But we ended up at 300 the first try. 300 records read write per
300.
second. Yeah. So we beat the
So you were
theoretical limit by 30
30
times.
times 30. And what did they say when you told them
They
about
they
that?
flew a film team out and they made a documentary. Honest. And they came and it was like 10 below and they're coming from California cuz they're not far from you guys, right? Pleasant
Right.
Valley or something where they were south of San Francisco a little while.
Yeah.
Oh no, you're down by LA.
Wow. Well, yeah, I'm down. I'm
Yeah, you're way
way
south.
south
Yeah.
border.
So it was hilarious. But we're still using Shade. And I read some of your stuff.
Okay.
I read one of your other articles about causality and predictive modeling, and I didn't understand most of it, I admit. But SPSS wrote a special version of Chade for us, and we still use it.
Oh, really?
Yeah,
I
well,
love that. So one of my books
it's not
is
that
the
special.
IBM SPSS Modeler Cookbook that I was a co-author on with Keith McCormick and Meta Brown and some others, and it was trying to get at with IBM Modeler, and Chade algorithm is one of the ones I used to use a lot to uncover characteristics of data, to do exploratory data
Yeah, most
analysis.
people use it
And
exploratorily, is that a word? And what we did
yeah,
instead was we prepared the data a little more. We put more work into the preparation, and so instead of p-values showing up, we redefined the the dependent variable to have basically profitability per customer,
okay,
and used ordinal instead of nominal. And so we drive the whole thing on EBITDA, and oh man, everybody loves it. And we can still throw 500 variables at it, but it's fully transparent. So it's kind of a
yeah,
halfway house between regression, which is understandable, and neural net, which has room for plenty of variables, but you don't know what it's doing, right?
right, yeah, yep. Shade and all the flavors of trees. The nice thing about shade, and they're all more interpretable. It's as long as they're shallow trees. If you get like 10 levels deep
Yeah,
or
no, I
15
limit
levels
it to
deep,
7, but I usually am
yeah,
about 5 or 6.
yeah, and even 5 or 6 starts getting a little tricky.
It's
If
goofy.
this
Yeah, it's
and
super
this
goofy.
and this and this and this and this, you have to think about it to tell a coherent story around that, because most people can keep maybe 2 or 3 conditions in their head,
No, I don't.
and then
Yeah,
you start.
I'm trying to think of Ed's name. Ed Lemur, I think his name is. He's a PhD. He's a professor at UCLA. I don't know how to pronounce
Uh
his last name, Lemur or Lemur. Anyway, Ed, one of my clients told me I violated every rule of statistical analysis, which isn't that surprising since I never really actually took a statistics course. But
well,
so I spent 45 minutes. I took his book. One of my friends who had a PhD from UCLA said, "You got to meet Ed. He's great. He'll like you." And so I went online to try to read his book because it was on their PDF, and they were all of it was turned sideways, and each chapter was its own file. And so I was really good with PDF, so I fixed it all, put it all together in one nice book, and I called him up and left a message, and I said, "If you'd like the new file all in one piece, right side up, just give me a call, and I'd love to talk with you." And so we talked for about 45 minutes. He called me right back, and he said, "John,
wow,
when we teach students statistics, we suck every ounce of creativity out of them." And he said, you don't violate the rules of statistical analysis. You go beyond them. You demand that it makes sense. So I felt a lot better after that.
yeah, but that is kind of a sad statement, because
Yeah.
statistics, it should be the most exciting and interesting topic.
Well, his book.
I really think, because most people think that
Yeah.
way. They really resonate with a good data story.
Yeah. Well, his book starts out with this great story where I think he went to Michigan, and he talked about how in the basement they were trying to model the U.S. economy. This is like in the 60s or 70s or something. And they couldn't figure out anything. They were asking the grad students what they thought and what they might come up with variables and how to weight them and all this stuff. And then they'd go up to the top floor with the students, and they would teach how AI had solved every problem, and it was just a matter of time until we have everything figured out. And that's how his book starts, with this incredible disconnect between the reality and the fantasy that we put forward.
Well, you appreciate this. I haven't put this in a public format yet, but I've accumulated a bunch of quotes about AI. Uh, about usually they're describe something like, we're going to solve this problem within 10 years with AI, whether it's automatic translation into a foreign language, or all those things that AI has been purported to do over the years. But then the question is, what year was it stated? And it's really difficult to understand just from the quote itself or figure out what year it was, whether it's the 50s, 60s, 70s, 80s, 90s, 2000s, whatever. But all the quotes are essentially the same. So we've been
Oh
living
yeah,
in
yeah.
this
So
world where
you can't
we're
see
on the
me.
precipice of a breakthrough.
You can't see me, but I have a similar list, and I was recruiting friends and family to be on a video where we just have a banner that says AI will, and each person says, cook your food, shop, drive your car, plan your college education. And I'm going to put on my Einstein hat, my Einstein mask. I was going to play Einstein. This is it. My wife says, "Don't you dare." But you'll be able to see it on. That's all I can put it on there. I got a wizard hat that I've been using for years, and it's just terrible. But yeah, it's hilarious what people think AI is going to do for them. Yeah.
Yeah, so part
Whoops.
of I view my role in the space right now is to try to. I mean, I love the promise. I mean, there is there is great potential with what the algorithms can do, but we still need a human in the loop, and that's what I was trying to get across in the article,
Yeah, it was
the
really
retail
good.
article, that we're not divorced yet from that. Because, and here's the example I usually tell, the story I tell when I'm teaching. So they're at a Strata conference in San Francisco like 5 years ago. They had an Oxford style debate on who should, this is in San Francisco, so keep that in mind.
Okay.
Who should your first hire be in a startup company? Should it be a domain expert or should it be a data scientist? Okay. Now, it's a Strata conference in San Francisco, so you know how the debate's going to go. But it was kind of interesting hearing what people had to say. And there are a bunch of discussions going back and forth. The more the whole debate progressed, there was someone said, "Well, with some googling and good common sense, you can solve all these problems. You can win competitions." And I started thinking about the competitions, and I was screaming at the screen, listening to the debate. Now, of course, I'm just watching a
Oh,
replay of it,
okay.
so they can't
Yeah,
hear
yeah.
anything I'm saying, which
I
is
do the
good.
same thing.
But I'm screaming at it because I was saying, would you do a Kaggle competition? What do they give you? They give you a data set in loadable format, rows and columns,
Which
right?
you never get in the
They
real
give you
world.
the That's right. You get the target variable, what you're trying to predict.
Oh,
You get the
that's nice.
metric to decide
Yeah.
what is a good model, what's not a good model. So I'd say, well, of course, once you get all that, you've solved 90% of the
Yeah,
problem.
right.
Just because
Exactly.
you solve a Kaggle competition, win an award there, doesn't say anything about the ability to solve problems in the real world, because the biggest hole, the biggest disconnect, and this is what I was trying to get at the article, is taking that business problem you're trying to solve, the decision you're trying to solve for, and aligning the data and the objectives to that business objective. And I could guarantee you, because I've never delivered a model in my career based upon R squared or based upon entropy
Right.
or something like that. It's always what they want to know is, how much money am I going to make from this?
That's why
How
we
much
do it that
time am I
way.
going to
Right.
save? It's right. But there's no algorithm that minimizes to time spent or to ROI,
Right.
unless you do something like simulated annealing or genetic algorithms or something like that. So all these machine learning algorithms, they're going to minimize, uh, you know, R squared, or they're going to minimize classification errors, or using entropy or Gini or something like that, which is not what we want to do as a business. So that's really the hard thing, is how do you connect those two worlds together
Yeah.
so that you can solve the right problem with the right error metric.
Well, I don't know if you saw my thing on RO,
I did.
AI ROI in 90 days. How about that for insane? I had somebody who's actually using AI with Tiny Clues, which is a French company, and when I told him that, he laughed at me. Like, you can't possibly do that. Nobody could do that. Yeah, we can do it. It's just
Yeah.
we we know which clients to go after. That's part of it.
So and part of it, I used to go into, and I can't say publicly who they are, but I
No,
used
that's
to go
okay.
into a newspaper that you've heard of before, and I used to go into their their headquarters on Monday morning, and by Friday when I left, I had to have a deployable machine learning predictive model that they could use.
Wow, cool.
And so go in there, and so they would have the concept laid out, and I'd have access to the data, and there are people there to help me build data I needed to build.
Yeah,
But the whole thing is, if you think clearly about the problem you're trying to solve and do it incrementally, like I was describing in the article,
absolutely
you
right.
triage.
Yeah,
You solve 80% of the problem first. Don't try to do what I see so many uh, data scientists try to do now. That you build a Hadoop cluster and you spend 6 months building data, only to find out 6 months later that the data isn't the right data for the problems that the business
yeah.
wants to solve, and you got to start over.
Well, and you
You know,
you can probably speak to this, but I try to explain to people I used to explain the fallacy of big data and bigger data in that the more data you have, the more spurious correlations you get. It's mathematical, right?
yeah. And so the joke I usually tell is the biggest advantage of big data is p values go down. Everything becomes statistically significant. That's the biggest
That's
advantage.
right.
Just because you get
Everything. Wonderful.
so so it's bigger data. It does help. There's some domains where it helps a lot, or some kinds of problems where it really helps a lot to have bigger data. But a lot of problems you solve, you don't need a billion rows. You need enough to populate the data space
Right.
and no more.
And to
And
validate
so
and
that's
stuff. Yeah.
and
We
to
tell
validate
people,
exactly.
if you don't have 100,000 customers, then you're not really in the statistical realm. You're in the, conjecture realm, kind of. For us, anyway.
Well, it depends.
Yeah. Right.
If it depends on how complex the behaviors are. If you've got a process that is linear and only requires, a dozen or 2 dozen variables to describe it, you only need
Yeah.
what, 2 dozen variables
My,
to describe it,
my
and it's a linear process. You need 25
Wait a
records,
minute,
right?
but where
Or
is a
okay, let's be
linear
generous.
process?
You need
That's what
100.
I want to know. Where in the
There are
world is it linear?
I'll give you an example
Okay.
of this that was really interesting. So I was building predictive models for Revenue Canada
Okay.
to identify non-filers and how much
Sure,
non-filers
that
owed.
makes sense. That's a good
That
one.
was that it was generally a linear problem, generally speaking, and so there's some problems that at least that gets you a good percentage of the way there. And then you can, once you get something like that to improve, because really what I'm after initially is let's improve the decision making process as it exists
Right,
now.
right. Get
And so
lift.
if a linear model does better, that's great. Let's get that out there.
Yes,
And then
I
let's
get it.
see if
Yeah.
we can build a nonlinear model to beat the linear model.
Well said. It may not be linear, but it might work linear for the moment.
Yes.
Right. That's what I like
And
about Jade. It's
that's what
not even
statisticians
close
try
to
to
linear.
do.
What? Yeah.
Yeah, statisticians spend a lot of their lives trying to, what I describe as cramming the data into the assumptions box. So if it's a linear problem, you've got to transform all the variables so that it fits the linear assumptions. And that's why I made a living as a consultant for years going into organizations that had marketing departments that needed models like in a period of weeks or a month that they couldn't get from the statistics group because that group was so concerned about the data being right and the model being right that they weren't able to improve the
Well,
decisions.
that sounds like
So
a good place to end. Watch out for the statistics people. Anyway, because we got to cut this off. But it's been so fun, and I think we should do this pretty often because I'll learn a lot if nothing else.
I'm learning a lot too. This is a lot of fun, John. I'm so glad you reached out. I'd love to have more discussions with you. This is a lot of fun.
Okay, we probably could have one on each of these points. The one I loved the most was confirm these technologies can actually do what they promise and that the company will collaborate to align their solutions with your direct business needs. What a great conclusion to that article. That was the greatest. That was really one of the best articles I've ever seen in this topic. So I really want to thank you, Dean. This is
Well,
great.
thank you very much, John.
And
Appreciate it.
and I always sign off with, and your friends will think you're smart. And this is one of the few that I think might actually achieve that. So have a great day. Thanks again.
Thanks, John. Take
Sure.
care.
Bye.